Alright, hi everybody. This is the IB package. This is topic 1, example 4. We're going to use a sample space as a weighted probability tree. So I'll show you what that means in just a couple seconds here. So according to blood records, 4% of Canadians have type AB blood. Based on surveys, it is thought that 10% of the population is left-handed. Assume that there is not a relationship between between handedness and blood type. Use a probability tree to estimate the probability that a randomly selected Canadian does not have type AB blood and is left-handed. Okay, so here we go. So we're going to take a look at this weighted probability tree. So first of all, our first choice might be AB blood. So we'll say AB blood, and then I'll put a bar over top, not AB. Now, the question stated that 4% of Canadians have type AB blood. So there is a 4% chance that that is going to occur, which means that there is a 96% chance that somebody is not type AB blood. Now, this is what we mean by a weighted probability tree, okay? We're identifying the probabilities of these events occurring. So the next thing that we're going to do here, the next choice here, the next branching, okay, deals with handedness. So let's say that we're talking left hand, right hand, left hand, right hand. Now it says that 10% of the population is left-handed. So that's 10% here, which means that would be 90% here, 10% here, 90% here. Now, notice that it's important what they set up here, that we're supposed to assume that there is not a relationship between handedness and blood type, because what that would do here is that would affect these probabilities. Just to keep this pretty straightforward and probably reasonably so, we assume that there is no direct connection between blood type and handedness. Okay? And so now, we get our outcomes here. Okay? The probability that somebody is type AB blood and is left-handed, so the probability that you have got AB, okay, and you're left-handed, is going to be the product of those two. Okay, so that's going to be 0.04 times 0.1. It turns out that is, oops, sorry, I don't want to make this too crazy, 0.004, okay, or 0.4%. And that right there, okay, oops, sorry, does not have type AB blood. I'm going to keep going and do the whole thing anyway, because you're going to do some more of these weighted probability trees, so you might as well have a couple of examples. The probability that somebody has type AB blood and is right-handed is going to be 4%, so 0.04. times, but in this case it'll be 0.9. And so this is going to be 0.036, or 3.6% of the population. Now, here's the one that the question's actually asking about. The probability that you don't have AB blood, okay, and you're left-handed. That is going to be 0.96 times 0.10. So 0.96 times 0.10, and you've got 0.096. Okay, or roughly 9.6% of the population. Now, thus far, that does not account for a lot of people. But here's going to be the big one. The probability that you're not AB blood and you're right-handed, okay, both of those are in the majority. That's going to be 0.96 times 0.9. And here's our 0.864. So 86.4% of the population is in this category. But this is the one specifically that the question is asking for.